Hi everyone, welcome back. So in the last video we talked about consumer and producer surplus and what that means for economic efficiency in our perfect equilibrium. In this video we want to talk about price controls, specifically a price ceiling and price floor, and what that's going to do to efficiency, right? It creates inefficiency and we're going to call that deadweight loss. So let's take a look at an example of a market for tacos. So here's our demand for tacos. We have 60 minus 8p, and our supply for tacos is 20 plus 12p, right? So we've drawn out our very rough sketch of the supply and demand model. I've also gone ahead and solved for our equilibrium price, $2, and our equilibrium quantity of 44, right? So 44 tacos bought and sold in our market. Now let's say that the government wants to interfere, right? So let's say that the government places a price ceiling of $3 in our market, right? So recall what a price ceiling does is it essentially dictates in the market that the price cannot be higher than this value, right? So if the government is setting a price ceiling of $3, that puts our price ceiling somewhere up here. Right, so this line, imaginary line that I'm drawing right here, let's label it PC. So let's say the value of this is $3, okay? Now, we need to ask ourselves exactly what a price ceiling does, right? Well, a price ceiling is saying, it is dictating that legally we cannot charge more than $3, right? We have to have a charge anywhere but with $3 and below, okay? So anywhere at $3 and below. So we can be anywhere down here. We can be anywhere down here. Okay. Well, is this price ceiling actually doing anything? Is it having an effect on our market? If the price ceiling is up here at $3, if the price ceiling is up here at $3, well, we need to ask ourselves, where's our equilibrium? Our equilibrium price is actually $2, right? Because our equilibrium price is $2, we're already below what the government is saying the maximum price should be. And because we're already below, this is a non-binding price ceiling, meaning that it's not going to have any effect on our market, right? It's not going to change our equilibrium. So this is a non-binding price ceiling. Okay. So what does a binding price ceiling look like, right? So from what we learned in class is that a binding price ceiling is generally below the equilibrium, right? It's somewhere below the equilibrium, right? Anywhere below the equilibrium, right? So let's say instead that the government is going to place not a $3 price ceiling, so let's change this value, right? Not a $3 price ceiling, but let's say the government is going to place a price ceiling of $1, right? So a $1 price ceiling. Okay. Well, is this price ceiling now having an effect on our market? Let's ask ourselves. If the equilibrium price is $2, then we know that yes, this is now going to have some sort of binding effect, right? It's going to change our equilibrium, right? Because the price ceiling will be somewhere down here. So let's use this purple line to draw our price ceiling. So I'm going to label this PC, and the value of this is $1, right? So now it's below our market equilibrium, and in equilibrium, we were all happy with a market price of $2, right? Everyone who wanted to buy on the consumer side was buying tacos, right? And they got to buy tacos, and everyone on the producer side who wanted to sell the tacos, all those producers were able to sell, right? But now the government is saying that, hey, your price can't be above $1, right? So the price can't be above $1, meaning that the price has to be at $1 or below. So it can be anywhere down here. And because our price is not anywhere down here, we're going to see the price move from $2 down to this line, okay? It's going to move down from that point to that point, okay? So now our equilibrium has been thrown off, and now we're going to have some inefficiency in our market, okay? So first, what I want to do is what we want to do is we want to ask ourselves what happens to demand and what happens to supply, right? So at a price of $2, when we were in equilibrium, 44 tacos were bought and 44 tacos were sold. Well, now that we're at $1, our demand is intersecting, our price ceiling is intersecting our demand at a different point, right? It's to the right of the equilibrium, and our price ceiling is intersecting our supply curve at a different point as well. That is to the left of the equilibrium. Okay, so let's continue to use purple to denote what happens now. Right, so our new quantity demand is shown by this point. So I'm going to call this QD new, and our new quantity supplied is shown by this point. Right, this is our QS new. Okay, and the value on the x-axis, our quantity, that's going to give us what those new values are, right? And does this make sense, right? Graphically, is this in line with our intuition about what would happen if the price falls? Let's think about it. If the price falls, the law of supply tells us that demand is going to, that the supply is going to fall, right? If the price goes down, then producers are going to supply less, right? And that's exactly what happens because we're going from 44 to the left. So our supply is actually falling. And the law of demand tells us that if the price goes up, our demand is actually going to increase, right? Our demand is going to increase because now more consumers will want to buy this product, right? Now more consumers want to buy tacos because the price has fallen from $2 to $1, right? So let's calculate these new values. Let's calculate the new values of our quantity demand and our quantity supplied. Okay, so at a price of $1, we want to figure out what the quantity demand is and what the quantity supplied is. So all we really have to do is plug this value in for our price for both of these equations. So when we do that for our quantity demand, we get 52. Okay, so we get 52. And when we do that for our quantity supplied, we get 32. Okay, so at a price of $1, now notice what happens. 52 individuals, we'll say 52 consumers want tacos. Okay, and at a price of $1, only 32 suppliers of tacos remain. Right, before we had 44, but now only 32 of them remain because the price has fallen. Okay. So what is true here? Now our demand actually exceeds the supply. Right? If our demand exceeds the supply, right, there is too much of a desire to buy this product, right? There's too much desire for tacos, but there's not enough tacos to go around. So what we call this is a shortage, right? So this phenomenon is called a shortage. And we can actually calculate the size of this shortage by taking the difference between our demand and our supply, right? So 52 tacos are desired, 32 tacos are available, so we have a shortage of 20 tacos. Okay, so our shortage is 20 tacos. And let's highlight this in green. Right, so we now have a shortage of 20 tacos. Okay, but the problem doesn't end here, right? Because we now have a shortage, we're going to have some sort of inefficiency, right? The shortage has created inefficiency in our market because our perfect equilibrium, right, our competitive equilibrium has now changed, right? So this is going to create deadweight loss. Well, how are we going to find the value of deadweight loss, right? Deadweight loss we're going to find by just taking the area of the consumers who dropped out and the producers who dropped out, right? It's essentially the whole in our total economic surplus. So how do we find that? How do we find that value, right? Well, let's think about it. Before, when we were in equilibrium, all of these producers were selling tacos. All of these producers that I've highlighted in this temporary red laser, they were all supplying tacos. in our competitive equilibrium. Because of this price ceiling, now only these suppliers remain, right? So what happens is these folk, they drop out, right? These folk right here, they drop out. So they no longer are selling. They are no longer selling tacos. Okay, so that's our loss on the producer side. On the producer side, I'm gonna now change colors to yellow. On our producer side, these individuals, they are let's just say that they drop out. Okay, so they're no longer participating in the market. Okay, well, what about demand? Well, before, these many consumers wanted tacos, right? In our perfect equilibrium, all of these folk, they wanted to buy tacos, right? But now, because the price has gone down, so now all of these people want tacos, right? So the demand has increased, right? Right? But what is true about supply and demand? Well, consumers can only buy as many tacos as are available, right? And we know that there's a shortage of tacos. All of these people want tacos, but only this many tacos are available, right? Only 32 tacos are available. So our new consumption will also just be 32, right? And if that is the case, let's change colors here, then only 32 consumers from here to this point actually get the tacos. And all of these people, they will miss out. They miss out on tacos. So no tacos for them, okay? But we don't really care so much about these individuals right here, because in our perfect equilibrium, in our competitive equilibrium, they were not in the market to begin with, okay? And because they were not in the market to begin with, we're only really going to consider these individuals, right? Because these individuals who were in the market before, they're not getting tacos now, because there's a shortage for tacos because of this binding price ceiling. Okay, so our loss on the consumer side are these individuals right here. Okay, so notice that now what we have essentially here is the area on the consumer side and the area on the producer side below the equilibrium, below our old equilibrium. This creates this total triangle, right? And the area of this total triangle is our deadweight loss. Okay, so that's our deadweight loss. Okay, so really what we want to do is we want to find the area of this deadweight loss, both on the consumer side and the producer side, and that's going to give us a good measure of how inefficient this price ceiling is on the market. Okay, so let's go ahead and calculate the area of the deadweight loss. Okay, I'm going to use the same color. So our deadweight loss, the area of the triangle, we know the area of a triangle, we know it's 1/2 base times height, right? Can we find the base? Yes, the base is actually going to be the easiest part, because the base of this triangle is just from this value to this value, right? That's what we're going to be looking at for the base. We're gonna say it's horizontal, so we're just looking on the x-axis. So on the x-axis from this point, we're looking at 32, and on the x-axis from the other end of the base, we're looking at 44, right? So our base is just 44 minus 32. Okay, so our base is going to be 12. Okay, great. We found our base. Now we want to find our height. Okay, we now want to find our height. So let's look at our height. Our height we're going to find vertically, right? We're going to be looking at the y-axis to find our height. Well, the height of this triangle is from this point to this point right here. That's our height. We know what this point is on the y-axis, right? It's $1. But now what we want to do is we want to find this mystery point. We want to find what this mystery point is on the y-axis. Okay, that's the final piece of the puzzle. Okay, so how do we find this point? Well, why don't we just plug 32 into our demand curve, and that's going to give us our resulting y value, right? That's going to give us our resulting y value. So let's plug 32 into demand. So let's plug 32, sorry, let me clarify. We're going to plug 32 into our quantity demanded, and we're going to solve for our resulting price. Okay, so let's go ahead and do that, and let me draw it up here. So we're going to solve 32 equals 60 minus 8p. Okay, so we're going to do 60 minus 32. So we're going to get 8p equals 28, and we're going to solve for p. 28 divided by 8 is going to come out to be 3.5, right? So the value of this price point right here is going to be 3.5. Okay, so there we've done it, right? We've now found the other point on our vertical axis. It's going to run from 3.5 to 1, so that's going to be our h, that's our height. So now let's go back and solve this. So our height is equivalent to 2.5. Okay, so now we found our base, we found our height, so all we have to do is plug this into our formula. And what do we get? We're going to get 0.5 times 12 times 2.5. So our dead weight loss is going to be equal to 15. Okay, so our dead weight loss is equal to $15. That is the total inefficiency that is created because of this price ceiling. Okay, so we have a hit to our consumer surplus and a hit to our producer surplus, and that's going to be relative to the size of what our consumer and producer surplus actually is, and we know how to calculate that from the last video. And so that's how we do an example of a price ceiling. Okay, and a price floor will be very, very similar to this. Okay, except it's going to be on the opposite side of our competitive equilibrium. Okay, so hopefully this was helpful. In the next video, we'll look at a price floor.